see if it's a consistent thing. If it is, I'll just work out 1, okay? What page are you on, Cal? Pick one. Do you want 23 or 27?
27.
Okay. This is page 278. It says, find the equation of a line containing the point. So we have point. A lot of times, remember, the author will put P beside to remind you of the point. We have the point -1, -3. And it's going to be perpendicular to this given line. So it's going to contain this point and perpendicular to 3x minus 5y equals 2. There's a couple of key things here. First key thing being this right here. That's the first place I would start. That's the only equation you have. Whenever you're talking about making an equation of a line, you have to have what first? Regardless of which form, the slope. You have to have the slope somehow. Either they have to give you 2 points, or they have to give you an equation to pull that slope out of. You have to always have slope to start with. Let me put that in your notes. You must always, it does not matter which method you prefer, that's not always, it doesn't matter which method you prefer, you must always have slope first. That's the first most important thing to you in any of these equation type problems. And they don't give us one, they do talk about it. They give it to us invisibly, well, hidden into that equation. Of course, with this relationship here, that it's going to be perpendicular. But first, looking at the equation, guys, let's see. We have 3x minus 5y equals 2. Do I see the slope, or do I have to work for it? Work for it. I mean, we know that when we're reading these lines, this is the form we're aiming for. Y equals mx plus b. That's what we want so that we can read stuff off. That's the friendliest version. So let's solve this thing for y. First, I'll get what's least attached to y onto the other side. I'm going to move my 3x over, right? Moving it, remember, changes the side and front. So that'll kill that one off. Everybody with me? Yeah? Negative 5y equals 2 minus 3x. We still would like y by itself. That's our objective, get y alone so we can look at this equation. What is in the way of it being alone? Yeah, negative 5 is attached by multiply, so let's divide by negative 5 everywhere, right? So y is equal to, I have to keep this page kind of high, sorry for that. The half of my screen's kind of being a little funny. So let's see, I'm going to get a negative 2 over 5 when I divide it into that piece. And then for the second piece, a negative and a negative looks like a positive to me, 3 over 5. Still see beside my x. You guys tell me, on my original, what's my original slope in this one right here we're talking about? 3/5. It's right there. I had to work for it, but I have the original slope. Is that what I'm going to use, or do I have to think a little bit more? Carmita, do you have a question?
Yes, I was wondering, how did you know that 3/5 was the original slope?
Because whenever you, so the question is, how did you know that 3/5 is the original slope that we're dealing with from the questions and the stuff that we're given? And the answer is, see how we have the equation up here in the problem. We know that any equation with x and y can be written in the form y equals mx plus b, like we have at the top of the screen. Once it's in that order, where y is by itself and all the x's are on one side and the regular numbers are on one side, we can identify the slope really easily. The slope is always the number that's right beside x.
Oh, okay. Thank you.
You're welcome. And so in this one, that's the original slope. We're not finished with the problem, though, so don't get too excited about this being a slope. That was hidden in there because we have to keep working. Perpendicular. You guys tell me, what's perpendicular? And Carmelita, you can tell me too if you want. It's where it crosses at a 90-degree angle. It's the opposite, right? So the perpendicular is opposite. That's what I call it to help remind myself. But what that really means to you is it's the negative reciprocal of whatever the slope is. We care about that here because the directions don't say, hey, use the same slope as this line we have. The directions say, no, I want a perpendicular slope. So we have 3/5. Oh, let me scroll down because it's doing the funny thing. So we have 3/5. To get a perpendicular slope to that, flip it. What's the number now? Okay, the 5 went on top and the 2 on the bottom. And you change the sign to negative. If it were negative, the sign would have been changed to positive, right? Opposite sign, opposite number. Opposite is what you think of when you hear perpendicular. So negative in front and flip the number. What if it were a whole number, like 3? Okay, you would flip the 3 over 1, which is 1/3, and the negative would go in front. Right. So even with whole numbers, you can deal with this. All that work, though, guys, just to get that. That's the most important thing you got in the whole problem. Yeah, so note, if you had m original equal to, say, 3, okay? The m perpendicular would be equal to, well, let's see, 3 is over a 1, right? Negative 1/3. Because you would flip that whole number to put 1 on top. That's not what it is here. That's just me making sure you know, yeah, there's a 1 under any whole number, so a 1 goes on top when you flip it. And the sign changes. So in this problem so far, we've gotten goal number 1. I mean, it was a pain, but sure, we got it. We got that perpendicular slope. There's something else we care about a lot. What point it's going to go through. So at this point in the problem, yeah, we've worked hard, but really this is all that's important to us. What's the slope of the line, and what's the point it goes through? Just like in the last section, yeah?
What about negative 2?
We care about nothing else. We only care about negative 5/3 and the point it goes through. And yeah, the negative 2/5 is trash. That meant nothing to us. We know the parallel perpendicular lines, only the slope matters. What if I had told you, hey, it contains this point, but it's parallel to this equation? What would the only difference be? When you got this original slope of 3/5, it would have just stayed the same. So if it had said parallel, you would have said, oh, it's going to stay 3/5, and stop there, and you'd be in the same place that we are now as a class. Got it? So these are like the building blocks you had in the last section, where you have a point and you have a slope. Now you use whatever it is that floats your boat. Y minus y1 equals m times x minus x1, right? Or y equals mx plus b. Either of those equations that you've gotten used to using to create your equation will work here. You guys like the point slope, is that correct? So since that's what I'm seeing people favor, I'm going to say, okay, well, we're going to use y minus y1 equals slope times x minus x1. Our point was negative 1/3. So we're using negative 1, negative 3. Is that the point? I can't remember. It's too high up. Okay. And then that was the slope right, or the slope right there. So let's just substitute in xy y minus, remember using this equation that you guys prefer, you only substitute in for the ones with the sub numbers, y sub 1. So y minus, let's see, minus 3 equals slope, which is negative 5/3, times x minus negative 1. So we're being careful with our substitution here. How are we doing? Oh yeah, we got to distribute that, right? To break down the parentheses. So negative 5/3 x plus negative 5/3. We still want to get y by itself. So we're going to subtract 3 from both sides. What's negative 5/3 minus 3? It's what? Negative, I'm assuming. Oh, I mixed up the order. Is that okay? Yeah, order doesn't matter, because no matter which order it's written in, I can always identify the slope as being the number beside what? X. Okay. And the other number is what again? Y-intercept. That's where it crosses the y-axis. And this number beside x is our slope. If we wanted to graph this then, x, y, we would say, okay, y-intercept is about, give me that in decimal. What is negative 14/3? It's going to be 4 2/3 or something? Does that sound right? Negative 1, 2, 3, 4. If there were a 5, it'd be something like right in there-ish, is where it's going to cross the axis. And then we have the slope. That's, slope is always rise over run. So we know that the negative 5 is telling it to go down 5, because the up, down, the rise is always up or down. The run is a positive number telling it to go to the right 3. Let me redo my little axis. This is horrible. 1, 2, 3, 4, 5. We said that was negative 4 2/3. Something like that. Then we said, okay, go down 5. What a horrible line to have to graph. Down 5, so that's going to be like here, right? Let's see. 1, 2, 3, 4, 5. And then we go to the right, how many? 3. It's like Battleship all over again. No. Where are we going? Right there. I don't have a straight edge, which you can imagine that it's going to go something like that, except straighter. Okay. Is this line that we expected, slope-wise? For it's going down, did we expect it to be a negative slope going downhill? Sure. And we know it's going to be fractiony stuff, so it would hit the line in a funny spot with the y-intercept. Now, if you wanted to prove to yourself that you did a good job, you could graph that original one, the 3x minus 5y equals 2. The same one right here that we wrote as y equals negative 2/5 plus 3/5 x. And it's going to cross this one somewhere exactly at a 90-degree angle, exactly perfectly. Nice. Without graph paper, I'm not going to attempt it because I'm sure my picture would look absolutely worse than it does now. But with graph paper, you would see a perfect intersection at a 90-degree angle if you graph the other line with it. So on the test, I would do that, to make sure you got it right. Yeah.